In this video, we're going to explore linear motion and apply what we've learned about differentiation to linear motion. By linear motion, I mean motion on a straight line. So you can have a straight line path, and you can have an object that just moves along the straight line. Imagine a car driving on a straight road, so something like that. As you know, the speed of a moving object is equal to, or can be determined by dividing the distance traveled by that object by the time it took for that object to cover this distance. So speed is distance traveled divided by time elapsed. If an object moves from this point A to point B and it covers a distance of, let's say, 10 meters in, for example, in 1 second, the speed of that object, or the average speed rather of that object in moving from point A to point B, is the distance traveled divided by the time taken. So it's 10 meters divided by 1 second. So the speed of that object, or the average speed rather, is 10 meters over 1 second, which is 10 meters per second. If it took the object 2 seconds, then the speed of the object in this new case will be the distance traveled, 10 meters, divided by the time taken, 2 seconds. So this gives a speed of 2 here 1, 2 here 5 meters per second. Another important concept is the concept of a velocity, which is a speed in a specified direction. I can tell you that the speed of an object is 20 meters per second. That's the speed of an object. But if I tell you the object is moving 20 meters per second to the east, then this is a velocity. We know that the object is moving towards the east, so towards the east at 20 meters per second. So it's a speed in a specified direction. Now, a common way to represent velocities is to use signs. So I can define, so we have linear motion along a straight line. So I'll just move here. So imagine this is a straight line path, well, a horizontal path. And we have an object. The object can move to the left or to the right. So what I'll do is I'll define this right hand side direction as the positive direction and the left hand side direction as the negative direction. So if I tell you that the object is moving at a speed of plus 20 meters per second, this means that this object is moving at a speed of 20 meters per second in the positive direction. If I tell you that the object is moving at minus 15 meters per second, the object is moving at the speed of 15 meters per second, but in the negative direction. So plus 20 meters per second, as written here, represents a speed. This is the speed component, 20 meters per second, and this positive sign tells you the direction. So in combination, plus 20 meters per second is a velocity. So this is a velocity. This is also a velocity, a speed in a specified direction. Negative tells you we're moving to the left. So you're always free to set your convention. You can say, because we're talking about linear motion, you're moving in terms of moving either to the left or to the right. And you can assign the direction to the right as being the positive direction and the direction to the left as being the negative direction. But once you do that, you must stick with your convention and be consistent. Otherwise, you get into trouble. By getting into trouble, I mean you run into trouble with your signs and you make some mistakes. So you need to be consistent with your convention. So the first thing you need to do when you're handling velocities or vectors is always assign your directions with signs. Give one direction a positive sign, another direction a negative sign. Another concept you need to be familiar with is the concept of a displacement, which is a distance in a specified direction. So consider this straight line path. Consider this reference point, I'll call point O. An object lies at this point A at a distance of 5 meters from point O. This object A has a displacement of 5 meters from point O in the direction to the right. So if I define this direction to the right as a positive direction and the direction to the left as a negative direction, the displacement of object A from point O is plus 5 meters. If I have an object here, B, at a distance of 10 meters, or let's just continue with 5 meters. So 5 meters from this point O, this object B has a displacement of minus 5 meters relative to point O, the reference point. Why? Because it's in the direction to the left of the reference point. So the distance is 5 meters, but the direction away from the reference point is in a negative direction. So a displacement is a distance. So the displacement of an object is the distance of that object from a fixed point in a specified direction. And we specify directions by using positive and negative signs for linear motion. What you find is you encounter functions. So you have a displacement as a function of time. So you have expressions that will tell you where an object lies at certain times during its motion. And for such functions, so every function s is equal to, well, a function of time. So let's say something like this. Displacement is 2t cubed plus 2t minus, say, 5t squared. So this is a function. It tells you, so where t represents time in seconds and s represents the displacement of the object in meters. If you want to know the displacement of the object from a certain reference point at a certain time, you just need to replace t with the time. So let's say after 1 second, replace t with 1 and you get the value of the displacement. The key thing is you have the displacement as a function of time, and if you differentiate this function, you get ds dt. So you get ds dt, and this ds dt represents gives you a function that tells you the velocity of the object at any time. So I'll differentiate this expression, and that gives, well, this is 2t cubed, so that's 6t squared plus the derivative of 2t, which is 2, minus the derivative of 5t squared, which is 10t. So this ds dt is the velocity of the object. So the velocity of this object is 6t squared plus 2 minus 10t. So at any time you can determine the value of the velocity of the object, because all you have to do is replace t with the time. So set times in seconds, so after 10 seconds you replace t with 10 and you can get the velocity of the object after 10 seconds. But the key thing here is when you have displacement as a function of time, you differentiate the function, you get ds dt, which is the velocity of the object undergoing linear motion. And you can think of, v is ds dt, you can think of this ds as the change in distance, the distance traveled, and dt, you can think of it as a change in time, the time elapsed. So it's almost like a speed. It's like the formula for speed, which is distance over time. But the key thing here is this velocity is a vector. Displacement is also a vector. Therefore, you have direction. So you can have a positive velocity or a negative velocity. And you know that the positive and negative sign tell you the direction of motion. So we're going to focus on examples that apply what you've learned from differentiation to linear motion.